Prove by induction that for any positive integer n, the sum of the first n natural numbers is equal to a half n plus 1. Whenever you do a proof by induction question, there are always 4 steps you need to follow. Step 1, the basis. So if n equals 1, you need to show that this is true. So the left-hand side would be the sum from r equals 1 of r up to 1, and that's just equal to 1. The right-hand side would be equal to a half times 1. 1 plus 1 is 2, half of 2 is 1. Therefore, is true for n equals 1 because the left-hand side equals the right-hand side. Step 2, assumption. All you have to do is assume that it's true for n equals k, and then replace n with k over here. R equals 1, r up to k equals a half k plus 1. Then comes the inductive step, which is where most of the marks come in. You need to show that it's true for n equals k plus 1. So if n equals k plus 1, let's write it out again. R equals 1, r, k plus 1. Well, we know that if you go up to k, you have this. And then you're going k plus 1 term. So you're just adding k plus 1 because you're just doing the sum of the natural numbers. We know from our inductive step that this summation is equal to a half k plus 1. So let's just replace it. Half k plus 1 plus k plus 1. Now, we need to basically rewrite this formula with k plus 1 instead of k. So we know our goal, and we can just put our goal to our side. A half k plus 1 plus 1 we'll write as k plus 2. So we know what we're working towards. Let's try and factorize out and make this expression. So first we can factorize out k plus 1 because that's on both terms. So k plus 1, you multiply by a half k to get the first term, and you multiply by 1 to get the second term. Now, because we have a half out the front, let's factorize out a half from that bracket. So you put a half k plus 1, and a half k divided by a half is just k. 1 divided by a half is plus 2. Look, we've reached the goal. So now all we have to do is rewrite this as k plus 1. So equals half k plus 1, then you have k plus 1 plus 1. Therefore, is true for n equals k plus 1 because it can be written in the form. Then all you have to do is write the conclusion step. So if true for n equals 1, then assumed true for n equals k, then shown true for n equals k plus 1, the summation equation is true for all positive integers of n. And this entire thing here is your answer.